Okay, so my question to you is what things would make a parallelogram? What things do you think make a shape a parallelogram? Four sides. Four sides is the first and the most important thing. It's got to be a quadrilateral. It's got to start off by being a quadrilateral. What's the next thing? What's another piece? Quadrilateral and what? Yep. Opposite sides, parallel. If the opposite sides of a quadrilateral are parallel, we can call it a parallelogram. That's actually the definition of a parallelogram. Very good. What's another set? What might determine a shape, a quadrilateral, as a parallelogram? Any guesses? If the four angles on a shape equal up to 360 degrees, if their measures add to 360, that actually just gives us that it's a quadrilateral. That won't give us that it's a parallelogram, because that is true for parallelograms, but it doesn't make a parallelogram. Yeah. If we have opposite angles of a quadrilateral congruent, is that going to give us a parallelogram? Let's just kind of draw it out here. If I draw that picture and I match that angle somewhere in the bottom right, if I match that angle somewhere in the bottom right, the question is that going to determine a parallelogram? If I draw about that angle, right, if that angle were to be like that, would that determine a parallelogram? If we closed it, if we ended up intersecting these rays? Not just if one set, though, right? We actually have to have both sets. That makes sense? We have to have both sets of opposite angles congruent for it, in fact, to be a parallelogram. But that would make, if both sets of opposite angles are congruent, we would have a parallelogram. We can actually just say opposite angles congruent gives us a parallelogram. If I make just a general statement, opposite angles congruent, it could be any set that I'm saying. I'm not saying just one set. Does that make sense? I'm saying it could be both. I haven't restricted that. Really, we have to have both sets, but if we just say opposite angles congruent, that kind of implies the second set are also congruent. Okay? So that works. What else? What else would get us there? What else do you think? Yeah, that would quadrilateral gives us the fact that it's a closed figure. Should say quadrilateral being parallelograms. First, it's a quadrilateral, then we want it to be a parallelogram. These are the things that make it. If I had two diagonals that bisected each other, right? So if I drew a quadrilateral where the diagonals bisected each other, would that quadrilateral also be a parallelogram? Does that kind of work? If I kind of tried to draw a picture where the diagonals were bisecting each other, does that give us a parallelogram in the end? Yeah, that one's actually true. And I know we're doing just an informal conversation here. We're not proving any of these. I can prove them for you if you'd like. But we're just not going to go there if we can avoid it right now. Diagonals bisect. Each other. That'll give us a quadrilateral. What's another one? There's another property of them in terms of the angles. What's another piece we used when we knew it was a parallelogram? We're going to reverse it. We're going to give the converse. The other one was that consecutive angles are all sets of consecutive angles are supplementary. All, I'm going to write the word all there. just to kind of imply all sets. If we have all sets of consecutive angles being congruent, we're going to wind up getting a quadrilateral. So, or supplementary rather. If these two add up to 1/8, we're going to get a quadrilateral. Okay? Which would then imply, you know, these two would also be supplementary, those two angles. Okay, and then the last one that's tough is one set of congruent and parallel sides. Just one set. We just need one set. We don't need anything more than that. One set of congruent and parallel sides are going to give us, like if I say these two sides are congruent, in order for it to be a parallelogram, we would need to like push that right side of the bottom segment up and connect it. We'd get a parallelogram. If that was up here, it would still be a parallelogram. Both congruent and parallel. Here's a parallelogram. Okay? These items are ways that we can prove a shape is in particular a parallelogram. Okay? What I want you guys to do right now is there's a worksheet that's sitting up here. I want you to come and grab it, and I want you to answer which ones of those are parallelograms and which are not. Is number 1 a parallelogram? Yes. Why? Opposite sides are congruent. Yep. Number 2 a parallelogram? Diagonals bisect each other. Number 3 parallelogram? That's the definition of a parallelogram. Number 4 parallelogram. No, because it doesn't look like it. That's a bad reason. No, because it's not one of those 5 theorems that we talked about at the beginning of class. Okay? This is actually, no, this one's a trap. So be careful. Trapezoid, that is. Number 5, parallelogram. Consecutive angles. Consecutive angles are supplementary. 90 plus 90 is 180. Right? Alternate or opposite angles are congruent. Number 6, parallelogram. No, this is another trap. So careful. This one's especially a trap because these two, we have consecutive angles being supplementary there, right? Just on the right-hand side. These set of consecutive angles are not supplementary. Really? Okay, next one. Parallelogram. Yes. Congruent and parallel sides. One set. There's a set of congruent and parallel sides. 8, trap or parallelogram? Yes. Yes. Diagonals bisect, right? Number 9? No, it's a trapezoid, actually. Careful. It's a trap. Number 10? Opposite angles are congruent and consecutive angles are supplementary. Number 11? Nope. Is that a trap? Is that a trapezoid? No, it's not a trap. So you don't really need to be careful. Just to make sure you say it's not. Number 12? One set. How about this? Parallelogram? Parallelogram? Nope.